My guest today is Matt Stratton. Matt, how you doing?
I'm doing well. Thanks for having me on the show.
Oh, you're welcome. What are you doing?
So I'm a solutions architect with Chef Software, and which is a fancy name for saying that I work with customers who are interested in our product to help them do proof of concept, proof of value, understand what it can do. So basically, I'm a sales engineer, so we call a spade, right? But really what I do is I fuel the love of chef. I help people understand why I can make them awesome.
That sounds like an evangelist.
It's like an evangelist, except I get paid.
I get paid?
I bet I
I'm an
get
evangelist.
paid. I get paid for selling.
Right.
But either way, but being an evangelist is a big part of the job.
Okay.
You know, it's a big part of being in the chef community.
I keep hearing chef. It's a topic that a lot of Windows people have. It's been big in the Linux world for a long time.
Sure.
It's just starting to make a splash in the Azure world and the Microsoft world. But I'm not sure I understand exactly what chef is. Can you tell me?
Sure. So fundamentally what Chef is it's an IT automation platform. So it's not really, sometimes people might say, oh, it's a tool for configuration management. And that's one of the things that you do with Chef, is you can manage the configuration of your systems. But really what you're doing is you're taking a look at the systems that are driving value in your application and saying, how can I work towards a more automated world? How can I take things that are being done in a manual way? So we all have in our organizations, we have people who are really smart, and we're paying them a bunch of money to do a lot of dumb stuff that isn't using their big brains. Okay. And we'd rather use their big brains to move the business forward.
You said dumb stuff, you mean like road stuff.
Road stuff, right, exactly. Like, I may have some...
Plumbing.
Exactly, right. The things that are, again, like you said, are rote.
It's not working right, go ahead.
Oh, they're rote or they're easily automatable. So Jess Humble has said before that the surest way to introduce human error is to have a highly routine task, highly mundane task done by someone very technical, and that's the surest way of doing that short of sleep deprivation or inebriation. So what we want to do is we want to be able to say, use the humans for what they're good at to move the process forward, move the business forward.
Right.
And this also allows us, when we talk about web scale IT and being able to move at velocity, we want to have trusted targets. We want to know our systems look the way that they need to. If I've got thousands of machines running my business, I don't have to, it's just not physically possible to have somebody do things in a manual way.
Sure,
so
walking around with those floppy disks and putting them in.
At the very minimum, right? Or even, running an SSA, PowerShell on a for loop on 1,000 machines. Okay. How do you know that you got them all? How do you know what state they're in? And even more than that, the most important thing about Chef to me is that it's the idea of treating our infrastructure as code. So just like the way, so when I say my background is in system administration. I've been in tech ops most of my career, so I'm speaking for the tech ops folks here, but I say, so our compatriots over in dev, over the last years, they've learned how to do some things right. They've got some really good practices around things like test-driven development and source control and version control.
All good things.
All good things, right? And hopefully your devs you work with are doing those things. So there's a lot of stuff that we can learn when we talk about the idea of DevOps, right? A lot of times the ops people see DevOps means like developers need to care about operationalizing their application and they should carry pagers and blah, blah, blah. But part of DevOps is also that ops can learn from dev, right? We can say, hey, let's take all those lessons that dev has learned and created in good practice and let's apply it to our infrastructure. So with infrastructure as code, what I'm doing is instead of creating kind of a set of steps of things to do, so in Chef, I'm defining the outcome I want. I'm saying this is the state I want my systems to be in. Okay. Chef's job is to ensure they're in that state. But the other thing that happens, and where by treating
Let's stop there. So
sure.
When you talk about the state, we're talking about a version of the operating system installed and the software that's also installed.
That could be part of it, things like that. So it could be, and the state could be as simple as there should be a user on the system, called David.
Okay.
And so what I'm doing, though, what I'm not doing is saying, create user David. Or run user add David.
Because David might already be on that server.
Well, because I don't actually know on the server what's the right command to run that necessarily. I'm just saying I want there to be a user named David. Chef knows how to take care of that for me. And an example is, this is a little more, think about this, number one, if we were to say in the Linux world. So on different Linux distributions, the way you install a package is different. So for example, on an Ubuntu or a Debian-based system, if I want to install a package, I do apt-get install nginx. If I'm on enterprise Linux, I say yum install nginx. Well, what I do with Chef is I simply say, package Engine X. I want a package called Engine X on here.
Oh.
Chef says, I know what to do with that. Then we can take that even more awesome and we say like user, like there's resources that cross Linux and Windows. So all I need to do is in my Chef recipe, which is what we call the list of state, I say I want a user called David. And I can run that same recipe on a Red Hat machine, on an Ubuntu machine, on a AIX machine, on a Windows 2003, on a Windows 2008, on a 2012 machine, and all you had to do was say literally the lines, user David. And Chef will say, oh, well, I'm on Windows, so I know the way that I do that is with this particular line of command that will do the thing.
Oh, okay.
So you're focused on outcome, right? Not the how. You're focused on the what. The how is abstracted away. So what we can do, so we want to be able, so we're declaring this, but we want to test it, right? We don't want to find out how our infrastructure changes happen by applying them to our environments. We certainly don't want to find out by once we put them to production. So we have this idea of what we call test-driven infrastructure, which means we're allowed to, we enable the ability to follow testing patterns. So there's tools that are available, and these are all open source tools that are supported by the Chef community. One is called Food Critic, so it's a linting tool for Chef style. So it's a set of rules that the community has come up and said, this is good Chef code. So it's static code analysis, so it's super fast, right? So you run that against it and it can say, okay, hey, this may either throw an error, this may cause a problem. You're finding this all out against just your static code right away. You can run spec tests. You can run a tool that we call Test Kitchen, where what it will do is it will spin up an ephemeral virtual machine, either locally or in Azure or in Amazon or wherever. It will apply the Chef code to it and execute tests, which can be written in any testing framework. They can be written in server spec. They can even be written in Pester, which is a popular testing framework that leverages PowerShell. And so what you're doing is you're executing those tests against a test machine that exists only to be tested on.
Okay.
So you can say, I know what's going to happen when I run this, when I say apply this new version of my configuration to dev, to QA, what I expect to happen.
And let's test that. Let's make sure.
Right, exactly. And that way I'll know. That way I can deploy my infrastructure change with confidence, just like we do with our applications. That's why we test our applications, so we can deploy them with confidence.
Oh.
So and eventually you are at the point where you move your infrastructure code with your application code, because if you're making a change to your infrastructure, it is likely being driven by an application change.
Sure.
So really the two things are somewhat tightly coupled. Mm-hmm. So that's a big thing that's in the Chef world. We look at it from the larger, it's more than just configuring machines though, because we're talking about being able to actually deliver quality and at velocity and scale. So Chef was born in the world of velocity and scale. You know, it was born in web scale IT, but it doesn't mean you don't have to be, you know, some unicorn company in Silicon Valley with 100,000 servers to have value. But know but a lot of that comes from those ideas, is that it can scale very easily. It's built to be able to think in that way. So the other thing that you can do, or that's valuable in Chef, is we have this thing called Chef Analytics. So this is where we want to understand. So we have the thing that's making the changes. Well, we need to, in order to be able to deploy at velocity with safety, we need to have visibility into those changes. So what Chef Analytics is doing is it's monitoring and measuring all those changes that are happening through any manner that Chef is manipulating your systems. So you can say, okay, so the Chef client ran on some nodes and saw that it had to make a change. Because Chef is running all the time, but most of the time it's not doing anything. Because what Chef is doing is it's taking your desired state that you've defined, saying, I want this thing to look like this. It's comparing it to the current state, and it's basically doing a test and repair. It's saying, do these things match? If they match, then don't do a darn thing.
So once you've deployed these changes once, then it seems like you wouldn't have to unless things change. Like if somebody accidentally deleted.
Exactly, right. That's the value of it, right? So it's saying, great, it deployed the change, but it's also going and making sure that it's handling this idea of configuration drift.
I see.
So now that being said, you want to know when it's happening. So Chef Analytics gives you visibility into that, and it also allows us to, for customers or people who are under compliance or regulatory requirements that have to write audit rules. So the Chef client's running on these machines, and it can be collecting information. Just because Chef did the things you said it did, that doesn't mean that the system is actually in a compliant state. So you can write these audit rules that maybe are based on formal policy like PCI or HIPAA or SOX, or they may be informal policy just for your organization, which is we never install Apache. So these rules are running, and it's collecting this information and comparing it, and then it's not fixing it necessarily, it's not changing it.
It's just letting you know.
It's letting you know so you can have a very nice visibility into this. These are my machines that are currently compliant. And it's great if you think about from an audit. I mean, auditing, you love this, right? Because it means, hey, you come in, you say, what's your compliance level? I say, look, I can tell you right this minute. I don't have to go and do all this discovery and live in this world of like, we're going to kind of figure it out as we go. And our product manager for analytics has said, that really security is just an extension of quality, right? And if we think about quality in a software project, you can't bolt quality on at the end. Right. We know that doesn't work to say like, oh, well, we'll add quality later. But we act that way with security, right? We act like, oh, well, we're going to fix this all in a pen test, and we're going to have an audit, and that's going to we're going to run security.exe and make it all better.
During the security phase, of course.
Right. So whereas if this is all part of our earlier test cycle, but using the same rules, so those same rules that I can run against my running machines to see if they are compliant, I can run those same rules against my infrastructure code while I'm testing it to make sure that that code will not create a non-compliant machine. So because we know that the closer to the defect we catch it, the easier it is to fix it. It's way better to catch a security violation 5 minutes after I write the code that creates it than 6 months later during a penetration test.
Okay.
And then the final bit I just want to mention is
Sure.
a product that we just announced at ChefConf at our conference a couple weeks ago, which is called Chef Delivery. So this is our continuous delivery platform for delivering software, and it's based upon the last 3 to 4 years of experience our group, our company's had of building pipelines, continuous delivery pipelines for customers, and seeing that patterns have emerged. So what this is it's an opinionated, prescriptive workflow for doing continuous delivery of your chef code, of your applications, of anything together. And the reason being is that, these are things we have, there's plenty of people out there who have built continuous delivery pipelines using tools that already exist, like Jenkins and Bamboo and Go and all these other great tools. But they're not solutions. And the thing is, most of our customers, their job is not to be awesome at writing continuous delivery pipelines. Their job is to ship their software.
Right.
So Chef is, we very much believe in the idea of where we give you all the tools, and every solution that we build with open source tools that are open source and available, and you can just build them. If you don't like how we provide the solution, go build your own, and that's awesome.
Are you providing as a set of documents, or are you providing a turnkey solution where you can just say, run these tools, and you'll have continuous integration?
In the case of delivery, it is an actual product.
Okay.
An actual product. But what's cool about it is that the pipeline is actually codified, and so it's just like we talked about treating your infrastructure as code. You define the pipeline not through clicking on clicky buttons, but actually writing extended chef code that you already know how to do for writing your configuration. So
chef code, is that a language?
So Chef is a domain-specific language that's extended from Ruby.
Okay.
So you can use regular Ruby in your Chef code, but you don't. I always like to say that I'm the best example of I'm the world's worst Rubyist, but I write great Chef code.
You were the world's worst.
Yeah.
Until today.
Yes.
Your match.
Yeah. So the nice thing about it is, it can sound intimidating to say, oh, I don't know Ruby, but the reality is, you learn how to write Chef. I could teach you how to write everything you need to know in Chef in 2 days.
Okay.
And what happens is you actually learn Ruby and you didn't know it.
Right.
So the thing is, so in delivery, this stuff is codified, right? So it is now code that's defined in that way, and all that stuff is stored in version control too. So when you make changes to how your jobs look, that's all driven from version control. So everything is treated like code. We believe very strongly in approaching everything in that manner.
If you're a chef professional, you're creating these desired state configurations, you're actually writing code, writing in this.
You are, and this is.
There's no user interface.
There is not. That's right. Yeah, there's no click and drag and drop. You are writing code, and what I tell my sysadmin brethren, don't be afraid of coding, because you've been doing it your whole career. We just call it scripting. And you've been debugging your whole career. You just usually call it troubleshooting.
Right.
So it's good stuff. And the thing is, the reality is it sounds silly to talk about an infrastructure automation tool this way, but Chef is fun. It really is.
What's the point if it's not fun?
And what's the point if it's not fun? And that's, I've said before, I work at Chef because I believe in Chef. It's not the other way around. I've been using the tool for a long time, been part of the community for a long time, and I chose to work there. So, and it's because it's fun.
Exactly the same experience.
Yeah.
I work for Microsoft now after years.
Yeah.
Being a fanboy.
Yeah. It's pretty cool to come back to that place, that did awesome stuff for you. So hopefully that was, there's a lot of pieces to it, but really it's a lot about abstracting away the how and focusing on outcomes. And if we think a lot about DevOps in general and Agile in general and the way that we like to work and lean, it's being outcome focused.
Okay.
If I can make a little quick analogy,
Sure.
In traditional IT, and I'm going to have to make sure I quote this properly. So this is something that Jez Humble, who is the guy who wrote the book on continuous delivery with David Farley, and he actually works at Chef now. But he said this, so I'm quoting Jez so that I don't sound smarter than myself. But he said, when we talk in traditional IT, we like this idea of command and control, right? We come top down, we dictate. And the irony is the military hasn't done that since the days of Napoleon. The military believes in maneuver warfare, right? The general up here does not tell the infantry man, go forward 20 steps, go take this, go fire this way, go this. They say, take that hill.
Right.
And you are on the ground and you know how to do that.
I see.
And that's kind of the approach to a lot of when we think about DevOps and things like this, is it's outcome focused, right? The team, and Agile is like this too, right?
Sure.
This is the idea of DevOps is just a natural extension of Agile. Is you sit there and you say, all that matters, in a well-functioning Agile organization, that product team, that feature team, whatever, they are a black box with inputs and outputs, right? Feature requests come in, sausage gets made, nobody knows how, sausage comes out, and it's delicious. That's it. Or it's not, and then we go make some new, and then we say, let's try it again, right? Let's try it again. So the same thing is true with a lot of this, which is, and so in a lot of ways, philosophically, that's kind of how Chef works, except it's outcome focused. You're not telling the system, here's how to install Nginx. You're just saying, I want this.
I see.
It's up to you. You know how to do the thing.
Excellent.
And then so I can focus on the things I care about. And I could be a developer who doesn't know the slightest thing about how to install Nginx, but I know I need it. So instead of, and the other thing that's great is these things layer. So it's very DevOps in that way, in that everybody within your organization has their different level of domain expertise. So the developers know certain bits of the app of how they should be configured. App admins know a bit, security knows their bit. All the cooks are layering together, right? And as opposed to doing it by hand, where it might be it all turns into a document that gets turned over to sysadmin to say configure the system this way, that maybe came from a page that everybody added it to. What you're doing now is you're collaborating through code, right? And that's a much more powerful thing. And at the end of the day, source control is really a communication tool more than anything else. So that's really where we're trying to teach people to think in that way around their infrastructure.
That has been really enlightening for me. I hope it's been for our viewers as well.
Thank you. Thanks so much for having me. It's my pleasure. Really, the pinnacle of technology is the fact that I can now watch every episode of Friends on Netflix.